Hello and welcome back to the video lecture series on Python programming. I'm Amit Kumar Das and I'm a senior research scientist in the data science lab, A.K. Chaudhary School of IT, University of Calcutta. So I think we have already got an idea about why should we learn Python programming, what is the motivation behind it, and also some good, what should I say, strengths or features of Python as a programming language. We also have got an idea about how the course is going to progress, what are the different things to be covered as a part of the program. So now all that context being set, I'm going to directly jump in to a basic introduction of Python as a programming language. So first of all, this is for the beginners. I mean, people who are completely new to programming as a whole. For them, let's try to quickly understand what do we mean by a program. When we say programming language and Python as a programming language, what do we mean by program in the first place? So just to give a quick and simple understanding, say you have a set of tasks to do, right? And that set of tasks, you want the computer to do it for you. Now, how you are going to give the instruction to the computer for doing each of those tasks? So that we do using a particular program. So program is nothing but a set or a sequence of instructions which we give to the computers, right? Now, with that being said, what does the computer do? It executes or it carries out the instructions for us, right? So that it can do that broader task that we have given the computer to do. So that is called program execution. Now, we can talk with each other as being human beings. But again, just think about it. Say, I know three languages. I know English, I know Hindi, I know Bengali. Now, can I speak with somebody who is also a human being, but who doesn't know any of these three languages, just understands, say, for example, German? So what do I need to do? Either I need to speak in terms of the language he knows, which is German, or he needs to learn one of the three languages, English, Hindi, or Bengali, right? So whatever is it, basically there needs to be a very common way of communication, a common language which is being understood by both who is giving the instruction, that is us, the human beings, and the object which is receiving the instruction, which is the computer, right? So for doing that, we have the programming languages. Programming languages are the set of rules by which we, the human beings, can talk in a language which is easier for us to understand, and that language can also be understood, obviously with some changes, we'll talk about that later, by the computer, so that we can give the instructions and computer can execute those instructions, right? So that is the programming language. What are the different types of programming languages? Again, just for the beginners, there are basically three types of programming languages. I mean, three broader types. People may get into more details and more subtle breakdowns, but we'll not go into that. Three broader types. One, which was a fundamental type of a programming language, is called procedural language, where all the instructions or all the things that we want the computer to do are given in one sequence, one by one in a sequence. So that is called a procedural language, and probably the most popular procedural language, as we all know, is the C language, right? Next, we have another set of languages where the instructions are in the form of functions. This is known as functional programming language. The popular functional programming languages, which used to be erstwhile used, not much in use at the moment, are Lisp, Haskell, and stuff like that. Last, which is probably the most popular type of programming language, where all the efforts are being put in at the moment, are called the object-oriented programming languages. The fundamental basis of object-oriented programming languages is the concept of object, the class and the object, right? So we will deep dive into that later on. But just to let you know that Python, that the language we are going to study as a part of this course, is an object-oriented language. And the other very popular object-oriented language, probably the mother of all object-oriented languages, programming languages, is C++, right? Let's now move into the next very important concept, which is going to be referred in very common, we'll be referring it over and over again. There is a concept of interpreter and there is a concept of compiler. So just remember that we were talking about the programming languages. We are giving instructions to the computers and we are trying to give instructions in a language which we understand, or which is kind of easier for us to, kind of follow, right? The programming languages. Now, obviously, as is, the computer cannot understand that. The only language that computer understands is the binary language, is the language of 0 and 1. So, what is being done in case of a compiler? Whenever it gets a program written in a normal high-level programming language, it converts it to a machine language. It converts the source code to a byte code, right? And that byte code, conversion to that byte code, is known as compilation, or the program is told to be compiled. Now, when we are trying to execute the program, what happens is that byte code gets executed. Okay. Now, that's one very popular mode of running the programs. But there is another way to run the programs where we are not immediately, once the source code is written, we are not immediately converting it to the byte code. It is kept as is. There is something which is called interpreter. When we are trying to execute the program, the interpreter then tries to interpret the language into something that the computer understands. It's pretty much like I'm trying to talk with a person in, the person understands German. I don't understand German. I cannot speak German. What is there is a translator who sits in between us, and whatever I say in English, the translator converts that to German. So that's the role of an interpreter in a pretty, what should I say, in a simplistic way. Now, what's the advantage and disadvantage? Compilers, they have the byte code ready for the machine to understand. So obviously, the execution is faster. It doesn't need the time to again translate the source code to something that machine understands. They are already there. So that way it's faster. The execution is faster. But what's the problem? The problem is whenever you want to have a change, you will notice that there is some syntactical or there is some semantic issue in the program, right? What's a syntactical issue? There is a problem in the basic coding itself, in the grammar itself. And what is the semantic issue? Say something has gone wrong in the logic part itself, right? So wherever it is going wrong, I want to correct it. But how can I do that? I can do that in the source code, but whenever I make a change in the source code, the byte code will still not get it. So I need to recompile that source code and get the modified byte code. So that is one problem with a compiler. Whenever we want to make changes, every time I have to recompile the code, and that recompilation takes some bit of time. It cannot be done at runtime. The changes cannot be done at runtime. Here comes the advantage of the interpreter. It is much easier. You can basically do the changes at runtime and again execute the code without any need for recompilation or something of that sort, right? So that is a big advantage of a interpreter-based language. But the problem is, obviously, it is going to be the execution of a interpreter-based programming language is going to be a bit slower, right? Now, the language that we are going to study uh, in the course, that is Python, is a interpreter-based language, right? So that is one notion we need to have. Now, before going into any further technical details, let me highlight a bit about the history of Python, right? And when we talk about history of Python, we definitely cannot leave out the contribution of this person whom you are seeing in the frame. His name is Guido van Rossum or Rossum, right? He was the person who conceived this programming language, and that was way back in the later 1980s, right? He was the first person who started the development of this programming language, Python. And how did the name Python come through? I mean, you may think that Python is coming inspired by the name of the snake that we have, right? It's nothing like that. There was a famous BBC TV show, Monty Python's Flying Circus, and that used to be a very popular show of Guido van Rossum, right? So he gave the name to this programming language based on that show, right? Now, the development of Python, he started in December 1989, and the first version of Python was released in January 1991, right? So it took little more than 1 year, maybe 1 year or a couple of months to develop. And the first version of Python was 0.9.0, right? Then Python 2.0, which is almost at the verge of getting obsolete now. I think this is the last year that it's going to be supported. So Python 2.0 was released in October 2000. And it included major features like garbage collection, support of Unicode, and all those things. So 2.0 was the first major version of Python. Next, in December 2008, there was one more major version release, which is the version 3.0, right? There were again a huge bunch of functionalities which are being added in this version, but there was one big problem: it was not backward compatible. That was an issue. So whichever code which was written in 2.0 had to be either migrated, the code had to be migrated, okay, or had to be rewritten in 3.0. So that was a big issue, right? So that's the reason why you will see for a long time both the versions 2.0 and 3.0 or 3.x was being supported by Python, because already a huge number of applications were being developed in 2.0. So you can't tell them to throw that away, right? So that's why the support is being continued for a long time. In June 2018, the latest version of Python, which is 3.7, was being released, right? So this is pretty much the history of Python, how it evolved through the different years. Now, some salient features. I think we have talked about most of the salient features in the last video itself, but just a couple of more. We all know that it's a high-level language. Python is a high-level language. High-level language means something which is easily understandable by a human being like us, right? We can actually read through the code and we can understand what is tried to be implemented as a part of the code. So that is a high-level language. And as I told some time back, it is an interpreted language. So it is an interpreter-based language, programming language. Now there are two ways it can execute. One, it can either you can write the Python code in the command line itself and run one step after another step. So that is more of an interactive programming style. The other one is when you write all the instructions together in a .py file, okay, and run the .py file. That's the batch mode or a script mode of executing a Python program. Now, very pertinent thing is, how do I start? So if I start with the programming, I need to have an environment for programming. So by far the most adopted IDE for programming in Python is Anaconda. Okay, so if you have sufficient space in your workstation or laptop, you should directly install Anaconda. It's basically a distribution system which not only consists of the basic installation of Python as a programming language, it also includes all the major libraries that are needed to start with Python programming. So that way what is there is, you don't have to break your head, or you don't have to bother about what to install and how to install, right? You have everything with you in the computer or laptop that you are working on. Now, how do you do that? You can simply go to Google and find Anaconda installation. Wherever you want to install, if it is a Linux based operating system that you are having, or you have a Windows based operating system, whichever operating system, there is a separate installer for each of the operating systems. You can take that and you can install it. Simple. Once you have installed it, you are done. Now if you want to use the IDE, you can simply use the spider IDE of Anaconda. How do you get the spider IDE? You can simply go to the Anaconda and you can simply click on spider. Okay, and once you click that, the spider will appear. And how does it look like? It simply looks like something of this sort. Okay, where you can do the programming. How can you start the programming? So you can just go to file and you can open a new file. This is a .py file that you are opening, and then you can start writing your own code. Say for example, I want to write a code, print hello world. Okay, hello world. So I simply go and write this, and either I can individual. So I go to run. If I want to run a simple one line, I can just click on this thing, and here is the console where you can see the output, right? So here you can see the output, hello world coming in, right? This is the output, right? Or what you can do is, you can have, if you have a set of instructions of that sort. So say for example, I have this hello world written multiple times, right? So hello world, hello world, hello world, hello world, and like this. I run it simply by clicking on this run, or I click on the F5 button. So if I do that, again, it will prompt me to save it. Say I save it as Python, say day one or something of that sort. So day one, and I do it. So you will see all the hello worlds being printed in the console. So either you can run it in a batch mode from run command, or you can individually select a particular line or a set of lines and run them individually by clicking on run selection or run current line, right? This is how you can run the. So this is about the installation of the Anaconda and how you can start working with the code, right? Now there are certain things that you might have to install which is not there in Anaconda. Say for example, a very specific library you don't have as a part of Anaconda. You want to install it. Something which has been contributed by some person in the open source community. It's not there in Anaconda. So how can you do that? You can simply do that using the command pip install. So pip is the installer in Python, right? Using pip, you can install a particular package. So that package, that name you can give in single quotes. You can give the name of the package. So pip install package, right? So that way the package gets installed. and that you have to do from the Anaconda prompt. Again, not from the Python, IDE. You have to go to the Anaconda prompt, which is here. So you have to open the Anaconda prompt, and from the Anaconda prompt, you have to write this pip, then install, blah, blah, blah. Okay. Now, once the package or the library is installed, if you want to start using that library, you have to do one more thing. You have to use this import command, right? So you have to use the import command. So you give the import, and then you mention the library name. Say for example, some package is the library that you installed, and then you want to use this library some package. So you do a import of some package. Like here, I've shown one example, import OS. So OS is one built-in library of Python. So you can start using the functions of this OS library by doing an import of OS. Hope I'm clear? So this is when you start to use Python using an ID, which is the Spider ID, which comes as a part of the Anaconda distribution system. There is also another default ID whenever you install Python. You don't install Anaconda, you just install Python. There is another ID which comes along with Python, which is called IDLE, which is obviously not as rich as the Spider, which has a lot of shortfalls. But again, if you don't have so much of space to install Anaconda, you can also go with idle, right? Now, for example, okay, this is the console that I was showing you, right? The Spider console, right? Where you have the space where you can actually do the coding, and then this is the console where all the codes are being shown, right? Whatever is the output of the code is being shown, right? This is the basic console. If you want to write certain comments, if you want to explain the code and write comments to explain the code, you can just do that using the hash symbol and then write whatever you want to write. That part of the code is not going to be executed, right? So you can do that. Next, in case you don't want to install anything, right? That is one thing. Second, another advantage is, say you move from one place to another. You want to work in the lab and then again come back and work from home. Then obviously, if you don't carry your laptop to wherever you go, you're going to have a problem, right? You are not going to have access to the source code that you have already developed and which is work in progress. So for that, what you can do is, to avoid that situation, you can use a cloud-based platform like a Google Colab. Google Colab is a short form of Google Collaboratory. Or you can also use the KAGGLE platform. KAGGLE is basically a portal where all the data science competitions are being held. But it also facilitates to do programming in Python, as well as there is another programming language called R. So it allows to program in both Python and R. Same for Colab, right? So what you can do is you can simply use the Google Colab and do your programming. So what I will follow in this course is, I'm going to use the Google Colab, which is accessed from this URL colab.research.google.com. And when I go there, I will be simply having this window that you see here, right? And from this window, either you can open a work in progress Python file. You will see the files with IPNYB, okay, the Python notebook files, right? Or if you want to open a new notebook, what you can do is you can open a new notebook using this link in the bottom, right? So that is the way you can use the cloud platforms to do the coding, right? So here you see that the cloud platform is open for me. I have opened the cloud platform, and here the same thing, hello work, okay, for a change, not hello world, hello work. So I'm printing this hello work here. So this is the output I'm getting. and here the code is there, right? And every time you want to add a new code block, you can simply go to plus code and you will get a new code block coming out here, simple code block like this one, right? And if you want to add a comment, you can use the plus text to do that, right? So this is the second option. So either you use your local hard drive, your local laptop or workstation and do the programming in Python, or you use some cloud-based platform like a Google Colab and do your programming. Whatever suits you, you can do that, right? In this particular course, I will be showing mostly my work in the Colab, right? So as I just told you how to get started, you can use the print command to print a particular string, like as I showed, when I have shown you hello work, right? Or you can print a particular variable where you type in the variable name, or you can just print a blank line where you do not pass any parameter to this function. So this print function is a inbuilt function of Python, right? So to print something in the output, right? Or in the output console. So you can use any of the three mechanisms. Either you give a hard-coded string, or you use a particular variable, or you can just print a blank line, right? So that's where we are going to pause for the time being. We have covered some bit of an introduction to the Python as a programming language. We have covered some basic concepts of Python. So when I come back, I will be touching upon the next very, very important topic in Python, which is the data types which are available in Python. So thanks for tuning in, and request you to stay tuned with the future lectures. Thank you so much.